Testing, testing. If anyone always wants to let me know in the chat you can hear me, it's always good to have a double check. I know one time my mic got unplugged or something and I was actually muted, so now I'm always overly cautious. Welcome, everyone. I already see almost like 10 people here. We're going to get started in a few minutes. While we're waiting for more people to join, in the YouTube chat, which if you're watching this on YouTube, should be in the right-hand side. If you're watching on the LinkedIn stream, chat should be in the same place. Feel free to introduce yourself. Maybe mention where you're watching from, or if you've ever put machine learning models in production. Maybe if you're working on an interesting machine learning project and you want to share a little bit about it, put it in the chat. It's always really fun to hear a little bit about the audience for me, but also everyone else watching as well. And again, we'll wait just a few minutes before we really get going through the content. Well, we're waiting. I'll put myself down here to make this a little bigger. I'll go in presentation mode when I actually start going through the slides. So this should be bigger. But a couple things also while we're waiting. If you want, you can open up a couple links to get ready for the workshop if you want to follow along. So one, you'll probably need to create a YLabs account unless you already have one. It's free. There's no credit card or anything required. It's very easy to sign up. You just verify your email, and then you should be good to go. And then you probably have a Google account already. We're going to be using a Google Colab notebook to run all the code today. Again, I'll share these later when we get to the hands-on part as well, but this is just if you want to go ahead and open them up and get prepped a little bit early. I'm sharing the links now in the chat. And I'll share these in the LinkedIn chat in a second as well. Before we get going in the slides. And then we're going to be using our open source library today called YLogs. I'm going to share the GitHub repo to that. And we always appreciate a GitHub star. So if you're logged into GitHub or if you need to log in, give us a star. We always appreciate it. And then if you want to stay connected after this event and ask any questions, especially around anything we covered or MLOps in general, we have a Slack channel that you can go and ask questions to. And I'm going to share these links just one more time in the LinkedIn channel while we're waiting. And again, if someone wants to say hello in the chat and just make sure they can hear me, I always appreciate that as well. And we'll get going here in a minute. All right. And someone did say, hey, Sage, a while ago. I assume you can hear me. No one's saying they can't hear me, so that's a good sign. So far, pretty quiet. We're just at 10, though, so some other people are probably going to be popping in here, and then we'll get going. But again, in the chat, if you want to say hello, a little bit about yourself, it's always fun. Someone said they can hear us, and someone said audio and video is all good. Thank you so much for confirming. And if you want to share maybe a little bit about yourself or maybe the type of machine learning projects you're working on, that's always fun to hear about in the chat as well. Again, both for me, but also everyone else in the audience. And, maybe I can tailor a little bit of what we're going to talk about to your project space. Seeing people come in. Again, we'll wait just like 2 or 3 more minutes before we get going. But feel free to say hello in the chat. Seeing people join in. Where's everyone watching from? I'm based in Seattle, Washington, USA. It's always fun doing virtual events. I used to do a lot of in-person events back, before COVID. In-person workshops, which I'd love to start doing again as well. But it's really cool switching to virtual and just seeing where everyone is watching from. Someone said, right now they're machine learning for mathematical expression recognition. Oh, that's interesting. Is that for like looking at an equation someone wrote and figuring it out? Or is that different? Someone said they're watching from Colombia. Someone said from Dubai. Awesome. It's so cool to see where everyone's at. Thank you for sharing. It's really fun. And again, for anyone who just joined, we'll get going here in just a minute or two. And if you want to share a little bit in the chat about yourself, maybe where you're watching from, or what type of ML space you're working in, it's always fun to hear. All right, I think we can go ahead and start going on the slides. And again, there'll be some slides we're going to cover some kind of high-level concepts, just so no matter where your background is right now, we'll kind of catch you up to a high level, a lot of ML monitoring concepts, but then we'll go pretty quickly into hands-on code and actually kind of implement a ML monitoring system ourselves, and you could take what we learned today and use it with your own project, hopefully pretty easily. Someone said, watching from Nepal in North Carolina. Awesome. And someone said, yeah, they were scanning a lot of documents and converting the expressions to latex. That's a fun project. I used to do a lot of computer vision at my last job, so I love always. I often do analogies with computer vision as well, so just warning you, I might do computer vision analogies. All right, so this is Intro to ML Monitoring. Again, I shared these links in the chat, but I'll share them again when we get to the hands-on part. So if you didn't get set up yet, that's okay. I'll share them again when we need it. What this workshop is, hopefully it's a super friendly introduction to ML monitoring. Again, like I mentioned, we're going to go through some high-level concepts. So it's kind of designed where there's no previous experience expected, but definitely knowing some Python and machine learning concepts will be helpful. But if you're pretty new to programming or machine learning in general, you'll still be able to run all the code. We're going to go through a notebook and I'll kind of walk you through it. So, potentially you'll feel like, oh, you don't know exactly everything that's going on, but you'll be able to go through and probably learn a lot if you stick through it, even if you're kind of newer to the field. So again, in the slides, we're going to cover some high-level concepts, and then we're going to implement ML monitoring. And you can't learn everything in about today's workshop's actually about an hour. I didn't adjust this in the slide. So again, parts of this might be feel fast-paced or challenging depending on like your background, and that's okay. Just keep learning after workshop and ask questions as we go as well. I'll be monitoring the chat as much as I can. Oh, and a quick part of the agenda is, again, we're going to do quick intro. We're going to do concept slides. Then we're going to do set up a system using an open source library and the YLabs platform to detect data drift, model output, and performance monitoring. That should probably take about 45, 60 minutes, depending on how many questions there are. If we have time, we'll move on to one of these other sections to fill the gap. If we want to, probably this open source ML monitoring with YLogs. But the notebook I shared, and that I'm going to share again, is going to have the stuff to run on the bias and tracing, even though we probably won't cover it today extensively in the workshop, but you can take the notebook and run everything from. Someone said, hello from Silicon. Hello. Thank you for joining. We're just getting started. We're going to go through some slides, and then we're going to do hands-on code and kind of implement everything. A quick introduction about myself. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. I get to build really cool projects using our tools and talk about it, how it can integrate with other cool projects. We build tools around AI and ML and data observability and monitoring. We'll see some of those in actions today. We have an open source library called YLogs, which is really cool. And then we have our YLabs platform. And then I'll talk a little bit about it later today. We just announced a project called LangKit, which is for monitoring large language models, or really any language model of any kind. So a lot of stuff we're going to cover today, you could kind of imagine maybe how you could use it in a large language setting. So everyone's probably used something like ChatGPT. I'm guessing this crowd has used something like that. So, everyone's using large language models now, and you can definitely use ML monitoring in that workflow. And then for the past decade, I've worked in software or hardware engineering and machine learning, mostly with startups and some small agencies, mostly around Seattle. And also I lived in Melbourne, Florida before, and I love making things with technology. And as a quick side note, I just got back from Japan and South Korea 3 days ago, so I'm a little jet lagged and did not sleep well last night. So if I seem a little extra sluggish today versus other workshops I've done, that's why. About you. So again, I saw a lot more people join since the beginning. At the bare minimum, if you want to throw in the chat, where are you watching from? That's always really fun to see. And then also maybe put a little snippet about why you're interested in ML monitoring. Have you ever put a machine learning model in production? Are you learning how to build machine learning models right now? Let us know in the chat. And then I'll also share this link again. I won't be looking at this Slack chat during the event right now. I'm mainly looking at the YouTube chat or the LinkedIn live chat, so post any questions there. But if you have any questions after the workshop, join the Slack channel and say hello. There's an intro channel there as well, so you can stay connected with other people in the audience. But also, it's a great place to ask questions. Someone said, I have experienced time zone drift. That's pretty good. I'm going to use that for sure. Someone said, hello from Paris. Awesome. Cool to see where everyone's watching from. But yeah, I've definitely experienced time zone drift, and probably a few more days I'll need to retrain my circadian rhythm with new data. All right, so setup again. When we get to the hands-on part after the slides, I will share these again. Really, the only thing you probably need to do that will take a minute is just sign up for the free YLabs account. Again, there's no card or anything. You just verify your email, and you will be good to go. Otherwise, we'll be using Google Colab to run all our code. So very minimal setup. We'll be using scikit-learn to train a machine learning model. We'll be using ylogs. Again, I'll talk about these when we actually use them a little bit more, but ylogs is a open source AI telemetry library. We'll be collecting telemetry, and then we'll be monitoring that over time in the YLabs platform. And then also, if you run through the explainability part of the notebook, we also use SHAP to get some explainability values in there. All right, so what is ML monitoring? And again, I'll ask you, if you want to put in the chat, have you ever used ML monitoring before? Or done some form of it? Chances are you've done probably some form of it. That could be you manually checking. A lot of people go in, they might have a model deployed, and if they don't have a system set up with logs or alerts over time, they might manually go in and see if the camera is still running, like the person that was talking about computer vision, that it's collecting the right data, that the light hasn't turned off so the data is not too dark and your model's still performing as you'd expect. But there's obviously way better ways to do this, where you can set up a ML monitoring system within your AI application pipeline or data. You can also use this just in data as well. We're going to be using ML in this use case today. We're going to be looking at inputs and outputs, but you're going to measure just data across your pipeline and also look for changes in quality problems there. But at a high level, your system will probably look something like this. You have your AI infrastructure. It's ingesting customer data if it's deployed. And then you have some sort of AI telemetry agent. Hopefully it's pretty privacy preserving. That's one thing ylogs does really good, is it creates summary statistics of your data. So no raw data actually leaves your environment. You're just sending these little kind of summary statistics, like a thumbprint of your data, to the observability platform. Makes it really lightweight, but also it makes it incredibly privacy preserving. So if you are working in something like healthcare, this can be a really good solution for that. And then you have your observability platform. You're aggregating all those statistics, you're visualizing them, you're probably setting up alerts, you have ways to explore them, you want to explain what's going on, and then within that, as you're analyzing all that data, you can get some sort of output from that, and that could be like a report or dashboard for you to make a decision on. That could be alert and notification saying, hey, we think the data drifted, or your model output isn't performing as you're expecting, you should go look at this. And then you can also do a lot of automated triggers and workflows. I love doing automated triggers and workflows. I talked about doing computer vision in the past, and one thing that made us really cool was just having a really tight loop on our deployed model, collecting new data, looking at the distribution of that new data. And if it was different than the training data, we'd probably either had a quality issue, or that was new data that wasn't in our data set, and we want to take that and then label it and retrain our model so it's more robust on it. So you at a bare minimum, in my opinion anyway, typically you're going to be wanting to measure for input data distribution drift and probably performance or model output as well. And then if a change occurs against your training data set or a rolling window of time, you can do something with it. Someone said their first model that was monitored was updated on a daily basis with a local Streamlit app. Kind of hard to set up, but it was fun. Yeah, that's awesome. And I think like you've probably experienced this. You're probably collecting, I assume, data in production and retraining your model, and that's why it was updating every day. And it probably was a little bit more of a robust model if you hadn't been doing that. But sometimes you don't want all the data either. All right, so why do we need ML monitoring? I already talked about kind of setting up that ML training, MLOps kind of life cycle. But there's a lot of stuff that can also go wrong, or changes can occur anywhere in your pipeline that you want to be monitoring. So model inputs, that could be data drift. Again, we'll talk a little bit about these at a high level in a second. But data drift is basically where the input data to your model, the distribution drifted or shifted away from the training data. So it no longer really matches. And chances are your model's just probably not making as accurate predictions anymore because it doesn't really match the training data. You have data quality. That can be a lot of different things. People could be manually entering it wrong. I said, like someone could turn off a light in a factory and now your camera data is all dark. Schema changes can be updated. And if someone updated a library and it changed a schema somewhere and you weren't paying attention, now everything could be wonky. It could be monitoring your model outputs. So you can kind of see, if your models are having different predictions over time. We'll see this in action. I think it'll make a lot more sense seeing it. But you can also be looking at like volume over time as a good indicator. Potentially, if you had a large drop in volume, something could be, again, wrong in your pipeline or in your physical environment. And then you want to be monitoring model performance, probably things you've seen before, like accuracy and recall, but also things like bias and fairness in production. How is your model performing on certain segments or groups of your data? And then you can also use explainability to kind of dig a little bit deeper in there. And then obviously, ML models probably aren't super useful for your business if you don't have business KPIs. So it's good to make sure that you are experience the benefits of your model that you're expecting. We have a saying: bad data happens to good models. Again, like I said, I'm tired. All right, so a couple data quality examples. And again, in the chat, has anyone experienced a data quality issue with a ML model or data pipeline? An example, like I mentioned, could be an input sensor could be damaged and causing bad data. Data was manually entered incorrectly. This is pretty common, right? People might be filling out spreadsheets and they accidentally hit a wrong number, and they could put a decimal somewhere or like another zero, and can really massively change your input data. I've also seen things like cameras pointing in the wrong direction, like someone bumps it, and if you're not monitoring it for any big shift between previous days, you might not know that happened until you physically looked at it. And then again, pipeline bugs can kind of happen anywhere in the pipeline. And just a little bit further in the data drift example. So that's, again, where the input data, the data you're feeding to your model, where you're expecting a prediction, that's changing over time. And it's very common to change over time from the distribution of your training data. And there's a lot of causes for that. It could be seasonality changes. Again, as a computer vision example, imagine if you trained a model to detect geese in the summer and they all have a green background because they're on green grass, and then you're trying to detect them in the winter and there's snow on the ground, so now it's a white background. That's a big change in pixel colors, and chances are your model's probably not going to be performing as well on that until you retrain with that new data. New groups of users could start using your product, or just consumer preferences can change over time. Like if you're shopping, trends happen and you want to be monitoring for that. Again, if you have an example, throw it in the chat. And then just a quick example of concept drift. That's kind of where the input data isn't necessarily changing, but the model output no longer really maps to the value you're expecting. So a good example that I like to use when I explain this is the housing market. If you took a simple housing model and you're looking at square footage and number of rooms, and you trained your model 10 years ago and you're still using that same model, it's not going to be predicting very good values anymore, right? Like it's going to be way cheaper. The housing market's gone way up. So you'd want to retrain your model with those new prices. Again, if you've seen an example, put in the chat. And then just real quick, I won't go too deep into this. We're not really going to be covering this today, but detecting bias in production with segmentation, you can segment your data into specific groups and see how your model's performing on those specific groups. So a good example of this is there was a tech company that had like a credit card a few years ago, and it was doing a very poor job, I think, of approving women. And so you could segment out your data in production by gender and see how it's performing on those segments. And then again, I won't go too deep in here, but there will be some code in the notebook that you can run where you can kind of gain some insights about why your model is making the predictions that it is. So it gives you a little insight of like, it thought these pixels were an elephant, or this specific tabular data was the most important feature for making the prediction. I think there's actually a housing data right here as well. And then just to hammer it home about analyzing ML application, and then we'll go into the code. You want to start with a goal of establishing where a change can occur. So you know this is a machine learning application. You've probably built it, or you're on the team that's built it, or you're consulting with them. So they have some sort of existing pipeline, and you can kind of look at this and understand probably where changes could occur and where you might want to set up monitoring. If you don't know, like, just get started by setting up the model input and outputs, and you'll learn a lot from that. And that's what we'll see today as well. So, sorry, 1 second. So we'll see the this today, and then you want to establish what can change. So you want to select a meaningful baseline. So this could be, again, I kind of like if you're looking at data drift between your training data and the new data coming in. That's a really good way to establish, like, oh, this new data no longer really matches my old data, probably trigger some sort of error there. So you want to figure out what you're trying to measure once you've established where you want to measure it. And then how to analyze it. So there's different ways to calculate data drift, but also if you've selected something else, you want to understand like how you would measure data cardinality or overall performance degradation. All right, and then one more slide before we open up some code stuff. I mentioned at the beginning, if you were here, we're announcing LangKit today, which is our language model monitoring open source tool. We have a blog post you can go check out here. And we have a workshop next week. And hopefully I'll be less jet lagged next week. I'm going to share the link here. You can register. We're going to be using OpenAI, their API, and using LangKit to monitor a large language model in production. And then we also have a VentureBeat article. So you can go check those out if you're interested in large language models in production and you want to understand how you can implement monitoring. We have some resources ready to go. And then if you're not looking at them right now, you can join the workshop next week. All right, so enough slides. Let's go ahead and get to the fun part, the code. We've all kind of covered some of the basics. I know we went through it pretty fast and not super deep, but you might have an understanding now of like why data can change and cause issues with your models in production. So I'm going to share these links again. This first one is to the Colab notebook. So this is what we're going to open up and follow along, running all the code. The second one is the only account you probably have to create to follow along. Again, it's free. Just put in your email. I think you have to verify it, and then you should be good to go. And then one more thing, if you want to, you can fill out this little survey, and we'll eventually send you some swag. I think we will select around 5 people that filled out the survey. And our shirts look cooler now, or at least I like these shirts better. They say no more MLOps. I think it's pretty fun. So you'll probably get a shirt like this, or a mug, or one of these really cute stress balls. So I'll give everyone a minute to open up those links. Also, if you're watching on YouTube, they're all in the description below. So you should be able to open them up down there. Make sure I have the right one open. All right, so once you open this up, you should get a notebook that looks like this. If someone in the chat wants to confirm that it did work for them, that'd be great. And then once you're here, you want to go to File, save a copy in Drive. This will save your very own copy of this Colab notebook, and then you can make any changes you want to it. And you can always bookmark this one to come back to if you break it. So again, go to File, save a copy in Drive. And I'll zoom in a little bit here. Hopefully this will be a good amount for everyone. Did the notebook open for anyone? Just want to make sure that it's sharing correctly. Someone said they copied it. Thank you. Awesome. Yeah. So I'm going to go ahead and do that as well. Save a copy in Drive. All right, so now we have our Google Colab notebook. If you've never used Google Colab, it's essentially Google's way of hosting a Jupyter notebook, which if you've never used that, it's a popular tool in machine learning and data science, where you can write documentation, code, output visuals kind of all in one place. And Colab is really cool. It gives you actually a whole little Ubuntu instance to run the code in. We'll see this in action in a second. And it comes with a lot of libraries pre-installed. So we'll actually just have to install like one library, I think, for us to run all this code. So go ahead and scroll down and you'll see this code cell. You can hit this play button and you'll see it's kind of initializing right now. The first one can take several seconds to run. After that, it should be much faster. You can see it's now connected to an instance here, and we can run all of our code. Oh no, go away. You can explore folders. You can upload files in here. It's a really cool tool. And also, you don't need to do this for this workshop, but you can adjust the runtime and get free GPU hours. So if you are getting started in deep learning or computer vision and you don't have a GPU at home, this is a really cool tool to kind of get started with that. All right, so if we run this next terminal command, and by the way, you can run them by, if you're highlighted, you can hit Shift-Enter, and it runs it and then moves to the next cell. So you'll see me doing that a lot in the workshop instead of pressing the play button. So we hit LS. You can also run these terminal commands in here. This kind of lists everything in the directory. We can see that kind of sample folder that already exists. And then let's go ahead and pip install ylogs, which is, again, our telemetry agent we're going to use today to collect information about our ML model. So this should just take under a minute to install, but one very important step when it's done installing, restart runtime. Because Google Colab comes pre-installed with some libraries, sometimes the dependencies don't match, and if you install something new, you have to restart the runtime here. So if you don't click this button, chances are you're going to get an error later. So I'm telling you now, restart the runtime. Otherwise, when you ask later why you're getting a certain error, it'll be because you didn't restart it here. All right, and then let's go ahead and import our libraries. We're importing ylogs, numpy, pandas, datetime. You might be familiar with a whole bunch of these libraries already. And then we're going to set a value on pandas just to display the entire data frame. So we can look at a ylogs profile in a little bit. All right, so let's quickly go ahead and train a machine learning model. I'm not going to spend too much time on the machine learning model. We're just kind of assuming you kind of know a little bit about it, but I will talk about what's going on and explain the intuition behind the model so we can troubleshoot it later. Let's go ahead and load in the Iris dataset. Has anyone ever used the Iris dataset before? Probably. It's kind of the hello world of machine learning. So if you've done a machine learning model, you've probably used this at some point. And then we want to go ahead and train our model. So I'll go ahead and run this, but I'll talk through it. We're importing neighbors from scikit-learn. And then that's a type of model here is the k-nearest neighbors, and I'll talk about the intuition in a second. We're setting the nearest neighbors to 5, so it's going to be looking at the 5 closest neighbors to that new data point that comes in, the new input data, and then make a prediction based on the 5 nodes closest to it. And again, I'll show a graphic in a second. We are getting the feature values for training our model and the target values for training our model here. And then we're doing a train test split. So we're just going to basically take 30% of that data, save it to test on, and see how our model did. And we're using something called Stratify, which kind of tries to get the even values for all the classes of your model to train on them. And then here, this is where we're doing the training. And then we're going to be doing the prediction. And we're going to get this score of our model is 97% accurate based on the data here. And again, so intuition of k-nearest neighbors is you would have a new piece of data coming in like this. And this is visualized in 2D. You have multiple dimensions, so it'd actually be looking at, in this case, we have 4 features, so it's looking at the 4 features in like 4 dimensions. But in this case, this is a good way to visualize it. You have this new piece of data. In this case, the K number is set to 4, so it's looking at the 4 closest neighbors. And in this case, they're versicolor, or 3 of them are, and 1 is a Virginica. What do you think the prediction of this new piece of data would be? It would be the versicolor, right? Because the majority of the nearest neighbors to that new piece of data is versicolor. And this is important to remember when we kind of troubleshoot. Spoiler alert, something might go a little bit wrong with our model, and it's good to understand how they work so you can kind of troubleshoot them in production. All right, so This cell is just importing like 7 CSV files because we're going to simulate our model being in production for 7 days. So we have a CSV file for each day, and then we're just separating out the target values just so we only use the feature values at first, and then we'll add target values to them later to look at the performance values like accuracy and F1 scores. But this just gives us a list here called DFs and DF target. And we can loop through this list to kind of simulate being in production. So if we look at one of these batches, it looks something like this. There's 150 rows, at least in this first one. And you can see that these are the sepal length and width and the petal length and width values here. So we just have 7 of those that we want to run through, kind of simulate being in production. Right, so first let's create a log with ylogs and see what that looks like. So I mentioned ylogs is our open source library for logging data pretty much of any kind. We're going to use it with tabular data today. But I mentioned we have cool tools around NLP and LangKit for like large language models specifically. We can also log image data or anything you can imagine that you'd want to transform into like a Python dictionary or a pandas data frame. You can essentially log statistics of those values. And like I mentioned at the beginning, they generate summary statistics of your data set. So we'll look at what that looks like in a second, but just keep that in mind that we're taking like these raw CSV files and then creating a profile of it. So it's just kind of give us kind of fancy aggregate values like the min, the max, the mean, a little bit more than that. But there's a lot you can do with those summary statistics versus just the needing all the raw data. So let's go ahead and look at what a profile looks like. Here we're creating a variable called profile. We're calling y.log on that batch, and then we're turning it into a view so we can view it, and then we're looking at it in pandas here. And you can scroll through and see all the different values. This is our profile. So we kind of saw a little bit about what our data frame looked like or what our CSV looked like here. And then here we're profiling it. So we have cardinality estimate. It's saying there's probably about 42 unique values for petal length here, 24 for petal width, etc. And then we have things like count. There's 150 rows. There was no nana numbers. There was no nulls. And then we get the max values, the mean, the median, the min, and then some other quantile distributions. And so just looking at these summary statistics, we can gain a lot of insight about our data, especially when we visualize them over time. Like I mentioned, we're going to loop through and see this kind of in production over a week and visualize that. And we'll learn a lot about what our model and data is doing over that time. And if you want to learn more about ylogs, go visit the GitHub link here. All right, so let's take that profile and write it to YLabs. This is where it gets really fun, writing these profiles somewhere, visualizing them over time, putting them in tools where you can set monitors and alerts on them and see visualizations. So if you haven't already, create that YLabs account from the link that's in the YouTube description or the one in the chat. Once you create the account, you should have a homepage that looks something like this. You won't have these projects. You might have some other toy projects that you get started with. This is what mine looks like right now. I'm going to go ahead and delete one of these. So you can hit create resource here. That'll bring you to this model page. But also, no matter where you're at, you can go to this hamburger menu, go to settings, and then go to model and dataset management here. So this is where you want to follow along. Again, if you want to get these API tokens and follow along and run the rest of the code, this is just kind of the last bit of a setup where you're going to have to grab something, put your own values in the Colab notebook. Otherwise, if you run it, you'll get some errors later on. But you can also just watch what I'm doing. But here, I'm going to go ahead and edit and delete this kind of test model that I had in here. And I'm going to create a new model. But I will give everyone a minute to catch up. So usually someone falls a little bit behind here. Someone said they get a error, invalid requirement, ylogs, ylabs. Interesting. Is that on the install? In your case, make sure, just from what you're sharing, make sure you didn't accidentally delete anything here. So it should have like this bracket and viz in there as well. And if you did accidentally delete something again, or you're getting an error, pretty much, like especially if you see me running it and I'm not getting the error, it's probably accidentally not running a cell or deleting something. Oh, someone said they get the error on a local Jupyter notebook. That's interesting. I mean, you should. Oh, well, did you pip install ylogs? And unfortunately, I can't see your computer, so I won't be able to spend too much time troubleshooting on it. But if you do want to run through the Colab notebook, it should work. And if it's a local one, it might be something in your Python environment, I'm guessing. All right, so I'm going to go back to YLabs. Again, you can ask me to cover this part again, but I do want to keep moving forward. So once you're in your YLabs account, go to settings, go to models and data management. Oh, someone said restart environment. Yeah, make sure, like I'd mentioned, if you do the pip install and you don't restart the environment, but you're getting there during the pip install. Yeah, make sure you didn't delete anything. I can't see your screen, unfortunately, so I can't help exactly or be much more helpful than saying grab the original link and maybe start with a fresh copy. Just save a copy in Drive and see what happens. All right, I'm going to go ahead and create a new model. I'll call this Iris Workshop. And I want to set the resource type to classification model. You can always come and edit this later, but we're going to be monitoring a classification model today. So you're using our Iris train model that we did. Yeah, I'm going to get the API keys now. All right, so it looks like it's going forward on Colab if I'm reading your message right. So I'm going to call this Iris Workshop, and then I will set resource type to classification model, and then I'm going to hit this add models or dataset. By default, on the free tier, it'll run in daily batches. So this just means like every 24 hours, it's going to look at all those profiles and trigger an alert if something changed, depending on how you set up the monitors. But you can set this up at different increments like hourly, etc. So I'm going to hit add models. Now I have my model number here for my new one. It's model number 191. Yours is probably model 1 or 2 or 3, much less than this. You can tell I've created a lot of models in this account before. So I'm going to go back to my notebook and go to model ID, paste in that model ID. Make sure you didn't grab any new spaces or new lines or spaces here. We want these to just be strings with no breaks in them. Go to the YLabs platform again. On the same page, just go to access tokens and then create a new token. I'll call this again Iris Workshop. You can call it whatever you want. Create an access token. This is going to give me my API token here. Copy that, go back in your notebook, paste that in the API key section. And then one more thing, we want to grab org ID. It's 2 places on this page. It's right here and right here. So I'm just going to copy it from here. And again, paste it in. And now if I run this, I should be good to go. And I'll wait a minute because I know this can take a couple minutes for people if they haven't created their account. Let me know if you want me to run through anything real quick again. I'll pause for a minute. All right, so again, you can ask if you do get stuck later, but I'm going to keep going. I will import the YLogs or YLabs writer from YLogs. And then here we're going to create a profile like we did before. But I also initialized the YLabs writer first. And then we're calling writer.write and passing that profile in. And this is writing a single profile. So by default, when it writes a profile like this, it's going to be the date and time that you run that code. But we can override it, which we do on the next cell. But let's go look in the platform right now, or at least I will. You don't have to see this yet if you don't want to. But I'm going to go look at my project now. I'll click in. We can see a little bit of data on our summary page. This gets more interesting the more stuff you add, but let's go look at this input tab. So here we have our 4 features now. These are our 4 inputs for our Iris prediction model, classification model. Let's go click into petal length here, and we can see that there's kind of a few dots here, and if we hover over it, it gives us our summary statistics that we saw in that YLogs profile. So this is cool. We can now kind of start seeing maybe the capabilities of getting those summary statistics and sending them somewhere, except for we just have one profile. So it's not that interesting. Like, this is cool. We can see on this profile for the day, the median was 4.2, the max was 6.8, the min was 1, but we don't really know how that compares to the previous days or days after it yet. And let's go back to the notebook, run the next code cell. This is going to do the same thing we did above, except for we're overwriting the date time here. and then we're just looping through that list. So it's writing 7 days of CSV files. So we go back to the platform, give it a second to write those up. It's probably already done. And then refresh. Now we should see something that looks like this. And if for some reason you just see like the one profile still, you can hit this batch profile lineage button, and this will automatically kind of take you to the whole lineage of your data profiles. So here now we can do some more interesting analysis just by looking at it. And again, we'll do some cooler stuff by setting up automated monitors in a second. But just by looking at this, what do you think is maybe happening to our data? And maybe how do you think it's affecting the model performance before we even look at the output? Right now, we just log the input. Typically, I actually, in production, probably would want to log input and output at the same time, unless I'm logging multiple variations of input in my pipeline. But just by analyzing this manually right now, what do you think is happening? So, these first 3 days, the median is 4.2, 4.3, 4.2, about the same. We can look at max and min as well, but I'm just going to be looking at the median right now. That's a good one to often kind of start with and seeing how similar your data is. We can also see that these lines, like the yellow lines, is the max and min. So we can see that they're all similar threshold. And then this profile on the 11th goes up quite a bit. So the median goes to 9.2. The max is 11 instead of 6. And then this one looks really wonky, although the median isn't that different, but we can definitely see the max and min is more different than the other ones. And then this one is really interesting. Everything is 0. Median, max, and min are all zeros. And then this one looks normal like the other first 3 profiles. So what do you think, maybe intuition-wise, maybe is what is going on here? And do you think our model is performing as we'd expect it to, with a decent accuracy? Spoiler alert, it's not. So, if this distribution, I know it is, we could go look at our training data set, and we'll do a comparison to our training data set in a second. But if this is similar to the distribution of our training data set, and then I know that these ones are pretty different, and this one is all zeros, which maybe we should never even have a 0 measurement for iris. That could be a data quality issue. Something's probably going on these 3 days. So let's actually go back to the notebook real quick. I'm going to run this one last code cell down here. This is writing what's called a reference profile. So in this case, we're taking our training data set, and then we're making a profile of it, and then we can compare any new data to that reference profile and see if the distribution has drifted a lot or not. All right, so let's set up a monitor, because looking at manually is cool, but we don't probably want to come in here and spend all of our time looking at this chart. We want to get pinged on Slack or email, or have some sort of automated workflow triggered. So we can go to Monitor Manager, or click this Setup Monitor button here. And we can see there's some preset monitors. We try to make it really easy to get started, but you can also go to New Custom Monitor. You can even go in and adjust all the JSON, so you can get really into the nitty gritty and do kind of anything you want with these monitors, which is really cool. I'm going to take this data drift preset and hit configure, and we'll just do some slight tweaks to it though. So we can hit edit on these sections. We're going to be looking for data drift. I'm going to change this. So Hellinger distance is what we use by default in YLabs to calculate the drift distance. It works well for tabular and categorical data. I'm going to lower this number to 0.6. That's essentially just making it more sensitive. So the higher the number, it's going to say the bigger the drift is before I set an alert. The lower the number, the more sensitive the monitor is to it. And then instead of looking at the past 7 days and seeing how much they changed, I'm going to select reference profile. And we only have one in here, so it's automatically selected, but that's our iris profile. And let's hit save. And now if I go back to the input tab, go to petal length, and then I can hit preview now. By default, this is going to run in 6 hours. Like I said, it's going to be like a 24-hour monitor. Every day it's going to run and see if in this case, the data distribution drifted. So here we can see on those 3 days that we called out that look a little weird, they all have an alert on them. So our monitor in this case was set up and tuned pretty good to pick up all those changes like we wanted. And now if I hover over in the preview, we can see the drift distance here is really big. The higher the number, the bigger the drift distance is. So it's 0.9, almost 1, which is the max. So there's a big change in data on this, even though it doesn't necessarily look like it to our eyes maybe. And then this one was a 0.6, so less, and this all 0.1 was a huge change because nothing was zeros before, I think, in all the data. So there's, it's saying, hey, something crazy went on here. So this is setting up data drift, which is kind of the bare minimum I'd recommend if you don't have any monitoring on your models or data in production so far. So this is going to catch a lot of things like the data quality issues by default. If you're just looking at data drift, you can get more nitpicky with it and set up more specific things or data quality like cardinality and stuff. But just by having drift, it can catch some of the data quality issues, but also catch when like you have new samples that you've never had before in your data set. Like if you were detecting cars in computer vision and your sample or your training data set never had any red cars, all of a sudden a red car is in there, it can trigger, hey, these pixel values look very different than the training data set. Maybe we want to take that new data, retrain our model with it, and make it more robust for the future. So you can do really cool stuff with setting automated workflows with this. I did a workshop using Toloka, where it would detect drift like this, and then it would kick off a crowdsourced data annotation job. So I could pay people to go annotate my data, give me the correct values, and then I can log performance, which we'll see in a second. And then I could see, I could retrain a model on that new annotated data, deploy that new model, and compare performance to each other on like a shadow deployment, and then see which one is performing better. So there's a lot of really cool stuff you can do with these kind of alerts being triggered and doing workflows in your pipeline. Just depends on what you're doing. So let's go look at our model output. Ignore that error. I think I just did some kind of not great pandas code here. All we're doing here is we are just adding the predicted output probability in class to our data frame. And like I mentioned before, if I was doing this in production, I might actually do these all at once where I'm logging the input data and output data at once. But just for this workshop, I made it a little bit easier to break it out. So we're just kind of adding to this data frame as we go and then logging the specific columns that we want in there. So here we have class output, probability output. I ran this. It did the same thing we did for the input data, except for it has the word output in the column, and that's going to automatically click it in, put it in this outputs tab. In this case, like we could put in this inputs tab. We don't have that many inputs, and we could kind of easily separate it out. But often you're going to have like hundreds of features, and so it's really helpful to have the separate output tab. And there's some features in here too that like when output changes here, you can find the correlation to the input changes. But let's look at our class output. So these are the predicted classes. We have those 3 that we expect on the first 3 days. And then the 3 days, the 11th through the 13th, that we think might be a little wonky. They do all look different than our distribution on the days that, in this case, we know they're the normal days. So this one is almost all Virginica, but there's 4 versicola. This one, this is the one that had some higher values, but it wasn't, as big of a drift. So we can see that the distribution is more similar to the regular days. And this one that we knew was all zeros is all one class. And then this one is normal again. And then, so why do you think we covered the intuition of the type of model that we used, the k-nearest neighbors? Why do you think this might be happening? Why would we be getting these predicted classes here? And if we go back to the notebook with this, right, we don't have any basically unit tests or anything for our data right now, which is, by the way, something you can do in ylogs. We can run that code in a second, or once we finish this ylab section. But if we had a new piece of data that was all the way out here, well outside of the distribution of our training data set, we don't have any tests right now that look for that. So new data can be out here, it can be all the way down here, and then it's still just looking for the closest 5 neighbors in our case. So when they're all zeros, the 5 closest neighbors is Setosa. So they're all being predicted Setosa. It could be, yeah. So, I mean, someone said special event that predicted the traffic there. In this case, I just made them bad. But yeah, like knowing why you're having an intuition of why your model's working and being able to look at just your input data and your output. We don't even have ground truth right now. We can kind of learn a lot about how our model is performing, which is really cool. So one last thing in ylabs here. I'm going to go ahead and log the ground truth for actual performance metrics. Let's go ahead and run all these again. This is just, again, adding the ground truth now, like we segmented them out when we imported those CSV files. So now we have basically everything in here. And we're just going to upload the ground truth to the ylabs platform and look at the class output prediction. And that'll give us scores in ylabs like F1 score, accuracy, etc. And it's very similar to like we've been doing before. We're just looping through or enumerating through all those data frames, and then we're just using this specific method here, though, log classification metrics, passing in ground truth column and the output column. And now if we go back to YLabs and go to this performance tab, we'll see that we have ground truth performance here. So we have things like accuracy, recall, F1, etc., our confusion matrix. And we can see on those 3 days that, yeah, they weren't very good, right? They dropped a lot in accuracy. They're all 90 plus before, and now they're all in the 40s or lower. And then, like I'd mentioned, you could probably have some sort of automated job, or this is what I would think about if I was setting up an ML pipeline. If I detected data drift, I'd want to alert myself, maybe even kick off the crowd annotation job, like I was saying, so you actually get ground truth like this. Nothing really quite beats ground truth, even though you can gain a lot of information just by looking at the input difference in the outputs. Having ground truth obviously is fantastic for knowing how well your model really is performing. So having someone do like some annotation, and maybe that's even yourself, it says, hey, something changed here, here's the new data, you go label it, and then you can look at the ground truth. And now that you have those labels, like I said, if it wasn't an error here, if it was actually just data drift, like new users came in, new colors of cars or something like I mentioned before, you can now take that annotated data and train a new model with it and deploy it. And then we don't have, I don't think I have, well, I guess I can compare, but they're going to be the same. So you could deploy another model, and then you could log that model with YLabs exactly like we did here. But then you can also monitor the comparison between those two models. So that one that you trained with new data, you can overlay it here, see which one's actually doing better. Hopefully that new data one's doing better, and then you could automatically deploy it. Like I'd mentioned, you can go through and this is collapsed part. If you want to, you could go and run this part of the code. I'm not going to cover the bias and fairness today in the workshop, but you can take this workbook, and if you were able to run through what we did now, you could totally run through this. Just again, set up a new YLabs project, and I'll kind of walk you through how to look at bias and fairness with explainability as well. Any other questions so far? We're getting close to our hour. I'll real quickly go through just some of the open source capabilities while people are maybe thinking of some questions. And then I'll share some links at the end if you want to kind of stay connected and follow up with me. So I'm going to go ahead and just create a whole bunch of profile views here with YLogs. We did this before, but I'm just doing it all at once here so we can kind of interchange them if you want to play around with them. Now from YLogs, I'm importing Notebook Profile Visualizer. This allows us to create cool visualizations right in our environment. And then I'm passing in 2 profiles here, profile 1, profile 2. So I essentially want to do what we did in YLabs, except for just with 2 profiles, compare them to each other and see maybe what the drift and distribution difference is. So I can run these. And this is our distribution kind of report. And it gives us the p-value error here. And by default, it's using KS-test, which is a different way of calculating data drift. But you can overwrite that. There's a lot of great settings and customization you can do in YLogs. You could even create your own if we didn't have the type of algorithm. It's open source, so you can implement it. I'm going to see here, this is pretty low. Or sorry, the higher the number here, the less likelihood of drift, I think, is. And then we can drill down into our histograms here. So if we actually want to kind of get visualizations for each features, again, these are overlaid on 2 profiles. These are pretty similar distribution. There's no drift detected. I can, visually see, yeah, they're not 100% aligned. I wouldn't expect them to be, but they're all within the realm of reason. Let's run it on another profile. Oh, first, let's actually just get the raw values. So this is all stuff you can overwrite too. So this is basically everything that is used to create this report here. It's giving us all the p-values, the algorithms, etc. Again, you can overwrite these in YLogs. We'll do this on another one. I believe this one should have some drift. Maybe I changed the profiles. Let's look real quick. I might have changed this last time when I was doing the workshop and didn't change it back. But if you change these profiles, like I said, we created a whole bunch of them. So you could change it from profile 1 and 3 to, profile 4. I forget which one is what profile. This one says drift detected. I think this is the all zeros one. So we're comparing now the distribution of that other data to the all zeros, and drift is detected for every single feature there, as we would expect. And if we visualize this, it's going to look weird. Let's see. The other one is, I don't even see the other value. Oh, because it's all zeros, I guess. And again, we can get the report. And if you want to, again, learn way more about all the configuration you can do here, check out the ylogs GitHub. And then one more thing, we talked about setting up those unit tests for our data. We had data that was way out of the distribution realm that we would never expect to be in our data set. So like we could say, we know we never want an iris that is a 0 measurement because we expect there to be some sort of measurement. And then maybe we know it should never be above 15 because that would be ridiculous or something like that. So we can import something called constraints from ylogs. I'll just run this and talk very quickly through it. We're just setting up, this is how we set up a constraint. You pass it a string. This can be anything you want. I usually type in whatever the rule is that I'm creating here. So I'm saying petal length should always be greater than 0 and less than 15. Creating a little lambda function here where what we're doing is looking at a distribution metric and on the petal length. And we're saying on that distribution metric, the max should always be under 15 and the min should be always greater than 0. And then if I pass a profile in here, I get this little report that's not the best to read yet, but we have a great visualization for it. But this just gives us a tuple here on all those feature tests that we designed here, saying these values 1 and 0. If this is 1, it passed. If this is 0, it failed. We can get this really cool visualization, though, where we can see that, great, they all passed except for 1 here. And then we have a const.validate validate we can call, which says if any of them failed, return false. If they're all passed, return true. So this is really cool. If you're setting up those unit tests, you can write them all out. Before you even run a prediction on your model, you could pass them through ylogs testing here and say, well, if it failed, like don't even run the prediction because we know it's going to be bad data. Here's another example. And those ones all failed. And then again, just what we're calling on is that distribution metrics dot max, and we're getting this value here. And we can see this was all 0, 1. And that's all the content I have for you today. I know we went through a lot. There are some good questions and then some areas where there weren't a lot of questions. If you do have more questions, again, join the Slack group here and ask them there. So if you start using this in your project, you need help, or you just want to comment on anything that you found useful, that'd be great to hear your feedback there. And again, I'll share the LangKit post if you're interested in monitoring LLMs in production. And GitHub if you want to check out ylogs. Hopefully you learned some new things, especially if you've never really set up a monitoring system or data quality checking system before. Hopefully this was useful for you. I know quite a few people stayed around, so hopefully it was at least interesting enough to watch me. But hopefully some of you followed through, and you can kind of see how you might set this up in your own projects with ML models in production. And Art Deckard, were you ever able to run your Colab? The monitoring section, you can just go through and run it. You can just open up, expand it, just scroll back up. I recommend creating a new project. It'll prompt you to put in the API key again. You can even just copy what you have above, but then you want to change the model ID to a new model. I said, great demo, thank you. Always good to hear. It's at least interesting. And if you go through this monitoring and bias section, again, I'd love to hear your feedback on that. So let us know in Slack how it went. You'll upload follow along. You'll upload profiles into segments, and then you can go to this tracing area, which will kind of give you a really cool view of the groups of your data in production. So I said, thank you for delivering the interesting session. Thank you so much for coming, everyone. It was always really great to have you here. I love getting people introduced to concepts like this. And I know it's something that like when I was doing computer vision, like I was saying, was stuff I was running into all the time, like data drift and data quality issues. And I was looking at Y-Labs, using them in our tool, and then I was like, I should just go work on that. It's really awesome. Again, links are in the YouTube description too, so this is going to be recorded and saved at this link, so you could bookmark the link if you ever want to come back, open up any of the links in the description, or just watch this if you want to rewind and go through anything again. And obviously you can subscribe. We do a lot of workshops, but also I'm starting to do more of like live podcasts again, getting guests on to talk about interesting things in the industry. So also, if you have an interesting story to tell or a project you're working on, hit me up if you're interested in coming in on our live stream and talking about it. With that, though, I'm going to wrap up the stream. So again, thank you so much, everyone. Hopefully we'll stay connected, and you can ping me in Slack or on LinkedIn. And I will hopefully talk to some of you all later.